Hey everybody, it's Tony from Adafruit, and I wanted to do a stream on turning a Raspberry Pi into an Amazon Echo-like device, so kind of a smart home assistant. And this is a follow-up from the stream that I did last week, where I looked at the code that Amazon actually published on GitHub to run a Raspberry Pi as an Echo-type device. And we kind of saw that the code was a little complex to set up, like it took a lot of time, a lot of different steps. It's written in Java and Node.js, and so there's a lot of complicated stuff. And something someone mentioned in the comments, and that I've also read about a little bit too, is a nice little version of an Amazon Echo type client that's just written mostly in Python, and it's much simpler, easier to install. It's called AlexaPi, and it's actually a port from the chip microcomputer, the little $9 small board computer. So somebody took that code and made it run on the Raspberry Pi with just a few small changes. So I figured we kind of jump in and just check out the code and see how difficult it is to turn a Raspberry Pi into something that acts like the Amazon Echo, where you can ask it questions, it can answer things. So let's just dive in. Let's look at kind of the full setup that I've got here. So let's go to this view. So you can see in the corner up here, this is the workbench. And so I have the Raspberry Pi Zero, so it's a little small little guy right here hidden. For all of these examples, I've been trying to use the Zero just because I think it'd be a good base for making your own Echo, like using a real small little device. And I have it just connected to, there's a push button right here that's a little difficult to see kind of on the end here. And so that's connected to GPIO 18 because we'll see the software, this AlexaPi, it's built to use a little push button to activate it. So one big thing with all of the code that uses, it's called the Alexa voice service that Amazon publishes. None of the code, as far as I've seen, uses kind of like a hot keyword. With the Echo, you say Alexa and it'll wake up and you can ask it questions. Whereas here, and in this example and in Amazon's example, you actually have to press a button to actuate the process, like to start listening to things. Now, what else I have connected to the Pi? So right here, this is a Zoom H5. It's a fancy little audio recorder. Now, I'm only using this. It's hooked up through USB, so it has a little USB port here, and it's just connected directly to the Pi Zero. The Pi Zero, I have this little fancy USB dongle, and oh, this is cute. It looks like my camera just died. So it did this last time I streamed. Now, luckily, so now I've got to call out Logitech. This is a Logitech C650, and this is the second time this webcam's done it. I have no idea why it freezes up. I think it's a USB bus issue, but I've got everything on individual USB buses, so don't buy Logitech webcams. Luckily, I have a replacement coming soon for this. That'll be a nice upgrade. So anyways, so I guess you can still see the picture. I mean, there's not much to see here anyways. But I have a little USB hub connected here. And oh, now the camera works. Awesome. So I've got a USB hub and it has Ethernet also. So the Pi is connected to the internet. And then right here is the USB connection to the Zoom. So the Zoom is just acting as a USB speaker and microphone. So it's got this fancy little microphone array on top here. But really you could plug in any USB audio device. Just make sure it has a microphone input and like a speaker output, and you connect it to speakers. So because the Pi Zero doesn't have any audio input or output connected to it. So the Raspberry Pi Model 2 and 3, they have a little analog audio connector that you can plug in, speakers, microphones, and things too. But for the Zero, you're kind of on your own, and so you have to use a USB device. Now over here on the web browser, so I've got a link to the page. It's called AlexaPi, and when this video goes up on YouTube, I'll have links down in the description that point to all of the code and things that I'm showing here. But this is the project, so it's created by someone named Sam Machin or Machin. I don't know if I'm pronouncing it right. But a real nice little project, much simpler than Amazon's example code. So this is written in Python, uses a few different tools to record audio, but I think you'll see the setup and usage is a lot simpler and easier to get going with it. So check out the GitHub repo. Now, I did have some problems. I tried to kind of run it as is and go through the setup process, and I ran into some things that maybe it's because I'm using a Zero, and like the code, it's kind of hard coded right now to output audio to the Pi's audio output. So if you're using a Zero that has no audio output, it's going to get confused and things aren't going to work well. So I'll show you how to modify the code. There's just a couple lines that we need to change to make it output audio to the external audio recorder, the little Zoom thing that I have here. And then it's also hard-coded by default to use the microphone from a USB audio adapter, so it won't use the Pi's audio input as a microphone. So just something to be aware of, and I'll show you in the code how we'll kind of change it to make it work. The other thing is that when you do its setup, it installs itself as a service that runs at boot, and you have to do it in a special root directory as the root user, and I ran into some trouble with it. Like the shell script that's included looks like it, I don't know, maybe there's an error with it, maybe it's because I'm running the latest version of Raspbian Jessie, but I saw a few issues in GitHub too where other people were running into this. So I'll show how to do a manual install that worked for me, where I just install everything that's needed manually and then run the code myself. And it wouldn't be hard to take that and make your own little systemd service to run this at boot. But you know, because the code as is, it's kind of nice in that it's only a Python script. It can run in the console. It's not like the Amazon code that required that you run a GUI application. You know, I'm actually using Jessie Lite, which has none of the desktop and stuff on this Raspberry Pi install. So okay, so let's kind of dive in. Maybe I'll do a quick little demo at first. So it's running on my Pi right now. I'm just connected with SSH. Now I'll hold up the zoom here. So oops, let me just see. I'll see if the camera can kind of show. So here's a Zoom recorder, and I'm going to speak into it. So the way it works, you press the button, and it's going to say that it's listening, and then you speak into it, and you keep the button held down while you're speaking, and then you let go of the button, and then it's going to send off your question to Amazon's Alexa voice service, get the response back, and then play it. So let's try this. What's the weather in Seattle? And it takes it a second for it to get the result.
Seattle, Washington, it's 57 degrees with mostly cloudy skies. Tonight's forecast has showers and a low of 45 degrees.
So it worked. I mean, it's just like we saw with the Amazon version. You know, it sends audio. It seems to get cut off a little bit the first second that it plays back. And I mean, you probably have to dig in a little bit more. So it's using the MPEG 123 tool to play back the audio. So it's weird that it's cutting it off. I don't know. I mean, maybe the audio clip that you get back from Amazon might need like some extra padding or something applied to it. But it does work. It's pretty nice. I'll try it again. So let's we'll ask it for a joke. So tell me a joke.
Bicycle stand on its own because it's too tired.
Why did the bicycle stand on its own? Because it's too tired. Okay, that's a good one. So you can see it's pretty nice. I like that it's all a console app here. Like I'm not doing all this GUI stuff that the Amazon code had. So let's kind of dive in, and I'll run through this. The install for this is actually quick enough that I think I can do it all, and we'll just kind of see so that you can follow along with this in the future if you want to install it and kind of see how I made some modifications here. So the first thing is, you know, here's the GitHub repository for it that has all the code. It kind of talks a little bit about the install that they suggest is you clone the code. They don't really mention it, but you're supposed to be in the /root directory, which means that you probably want to run sudo-i to get an interactive shell as the root user, and then go into that directory, and then run the setup script. But like I said before, I ran into some problems. The setup script, it fails at a certain point for me. Like it's doing this ifconfig call that it looks like the shell script has an extra space that causes problems. So I would say let's not use the installation they have, but it's pretty easy to do. They kind of mentioned this advanced install about how to set it up yourself. I mean, if you're curious, just look at setup.sh and just see what it does. So it doesn't do a ton of things. It's pretty easy to follow. It's just installing some dependencies. It sets up the little service that it includes, and then it asks a bunch of questions about, you have to do some setup on Amazon's website, and it saves them into this credential.py file. But I wasn't seeing it save this file when I ran it, so something was up with it. And then it gets the IP address because it has to run this little web server to do the OAuth authentication, and you go through that kind of process, and it's actually pretty easy. It's much easier than the Amazon code. So okay, so very first thing to do, you know, get your Pi set up. Like I said, I'm running Raspbian Jessie Lite, the latest version. I've got my audio device connected, and you can actually see I did not, in the previous video, I actually disabled the Pi audio output and input just because it was causing problems with Amazon's code. Here I have it enabled, and you can actually see if you run aplay-l, this will list all of the audio output devices. So you can see card 0 and this card 0 device 1, like device 0 and 1. These are the BCM2835, so that's the Raspberry Pi like GPIO processor or part of the CPU. So this is basically the native audio output on the Raspberry Pi. Problem is, on the Pi Zero, there is no audio output. Like, the device still exists. I mean, it's still there. Same CPU. It still has all that hardware. It's just you don't have a physical audio connection available. And then you can also see card 1. That's my Zoom H5 down here. So if you plug in a USB sound card of your own, it might be called something different. But you want to make sure when you run aplay-l that you see card 1 is your USB audio output. And then you also want to run arecord-l. And this is going to show all of your audio input devices. And here you can see, I have card 1. There is no card 0. It looks like, this one's not set up for any Raspberry Pi audio input because the 0 doesn't have one, obviously. But I can see at least, okay, card 1 is my Zoom H5. So that's good. Like, my Pi can see my audio devices. Everything is good with that. So the first thing is, let's go through the setup that you have to do as a one-time step on Amazon's website. So they mentioned down here, you have to go to developer.amazon.com, and you go through a little bit of a process here to do some setup. So I'll do that now. So let me just load up this page, and it probably wants me to log in again. So yep, let's do this. So I'm logged into the site. This has all kinds of stuff for all the different services Amazon has, but you want to go into Apps and Services, Alexa, and then the Alexa voice service on the right here, and click Getting Started. Now here you'll see a list of every device that you've created for this, and I think the way it works is like every device that you create, you're supposed to create a new product that you register inside of here. So let's do this. Let's register a product. You want to do the device type. And inside of here, you give it a unique ID. So I've already used, they suggest using AlexaPi, but I've already used that. So I'm going to call this AlexaPi 2. How about, it's nothing crazy. Now, device name, I'm just going to use the same thing. I think device name is just a fancy name that it prints out. Device type ID, this is important though. Remember the value that you use for this. Then click Next. And now you have to create a security profile, and what you're supposed to do is create a new profile, and you're supposed to give it a name, and I'm just going to use the same name here, AlexaPi 2, and remember this value because you're going to need it again. Description, I think, is just a fancy description, doesn't really matter, so we'll put AlexaPi 2 again. Click Next. Now web settings, so now it loads up, and we'll need some of these values in a little bit here, but first click the web settings tab. And now you can see, and you want to make sure that under security profile, the profile that you just created is selected. So AlexaPi 2, so I make sure that's selected. And here we have to set the allowed origin and allowed return URL. This is like a part of the OAuth scheme where you kind of tell Amazon's web service, hey, my device, when it logs in, after it successfully logs in, redirect back to a URL that I set ahead of time here. So it's a little more secure. It's like the device doesn't say where to go back. You've kind of pre-configured it ahead of time. Anyways, what you need to do, click Edit, and we need to add some URLs here. So the instructions call out using localhost, like using HTTP localhost 5000. Luckily, they don't use SSL, so there's none of the annoying steps that we saw in the Amazon code where they had to set up SSL certs and stuff. You don't have to worry about that because honestly, for a little local device here, you don't need SSL support for this. It's not some production thing we're doing. So for allowed origins, so let's put in what they suggest. They want to do localhost port 5000, but you also probably want to add http:/Raspberry Pi port 5000. So the host name of your Raspberry Pi, and if you've renamed it, set this to your host name. And the reason you want to do this is because we're going to do this authentication step from my computer here. So it's going to access my Raspberry Pi. And when I access my Raspberry Pi in the web browser, I'm going to use this address, Raspberry Pi 5000. And so I have to make sure that I use that same address in this registration here. If I didn't have this in here, if I only had localhost, the authentication will fail. And Amazon will say, hey, it's trying to redirect me back to the Raspberry Pi, but I've not been configured to allow that, and so it just fails. So it's a little bit of a weird step. You just need to be careful that however you access the Raspberry Pi, make sure that it's been configured in the security settings here to allow you to use that URL. So like this local host setting, really would only work if you run from the Raspberry Pi itself and access that web page. So you'd have to boot up the whole graphical user interface and use the web browser on the Pi, but you don't need to do that. So just make sure to add both localhost and Raspberry Pi 5000 here. And for return URLs, they say to set localhost port 5000/code. So I'm going to do that, but again, I also need to add that Raspberry Pi port 5000/code. So let's do the same thing here. So okay, so I've got both those set. Click Next. And now it's going to ask some questions. It only needs the category set, so we're just going to do other. Description, I'm just going to put AlexaPi 2 here, doesn't matter. Timeline for commercialization, TBD, doesn't really matter. How many am I planning to commercialize? We'll say 0. So click Next. Enable Amazon Music. I've not used this. I don't really know if this is going to work or not. I'm going to say no, because I'm sure it's going to ask me more questions, and I don't really care about that. So we'll say no, we submit it. And so, so now it created AlexaPi 2 down here. And you can go back and you can edit these settings if you got something wrong. But you just want to make sure that you've got this. Now keep this page open. We're going to need some of these values in a little bit here. So, so this is the setup we've done from the web page. Now we're ready to go to the Pi, and the first thing we want to do is clone the code that they have in the repository here. So let's do git clone, and we'll put the repository URL. So this is going to pull down the source code that they have, and let's go into their directory here where the code's at. And there are a few things we need to do. So normally when you follow their setup instructions, they have you run the setup.sh, and you have to run this as a root user from within the /root directory, because the service that it includes is hard-coded to assume that it runs under /root. So like I said, I'm not going to do that because I want this to be a little more flexible and let me run the code however I want, and then I can later build a little systemd service if I want. So so the way the code works, you have to put in some configuration into a creds.py file, and they include this example_creds.py. And so what you can do is we can just copy that. So let's copy example creds into creds.py, and then we want to edit creds.py and fill in some values here. So product ID, so this is the name of the product ID that we created in Amazon's website here. So if I go to my AlexaPi 2 device, it's actually, I think, device type ID that you want to use here. So use that exact value. So AlexaPi. Security profile description. This one I want to set to the value in my security profile settings, security profile description. So AlexaPi 2 is what I want. So I'll copy that out, and we put this value in here. And then security profile ID, I want to use the value right below that in here. So copy this out. And let's see, and I'm just going to end up deleting this device after the stream, so it's not a big deal if I'm showing these values here, but you generally probably want to keep these values secret. The client ID, so I want to use this value. Copy that, and paste that value in. And then client secret is the last value on here, so copy that out and paste that in here. So, so that looks good. Refresh token, leave this alone. It's actually going to set this itself. So save the file and then exit. And now I need to run this little auth_web.py. So this will run a little web server. Then you have to go to that web server. It'll redirect you to Amazon. You do this little authorization step, and then it redirects you back to your Raspberry Pi. And that's how it actually fills in this refresh token. It'll actually, once it gets redirected back after successfully logging in, it'll get a refresh token value and it'll plug it in here. So now we want to run the web server that it has. So let's do auth_web.py. So run this. And I'm sorry, actually there's some steps that I skipped here. So before I run this, we need to do some installation that I've already done here. So normally, like I said before, there's this setup.sh that you're supposed to run, but because I'm not running it, because it had some problems, I'm just going to do the steps that it has as like the one-time initialization. I'm just going to manually copy these out and run them. So you want to go in and copy out this apt-get install line right here. So this is going to install a few dependencies that the software has. So I'm just going to paste this in. And for me, because I've already installed these, and sorry, you have to do this as root. So yeah, I'll go back here. Oops. Don't want to hit that. Let's go back to the start here. And yeah, you want to run this as root, and it's going to install a few little things like the MPEG-123 audio player. So for me, it says I've already installed them, but that's okay. For you, it's going to go through and install all this stuff. And then the other thing that you need to do right after that is this pip install-r requirements.txt, and you have to do this from inside of the AlexaPi folder because there's basically this requirements.txt file. This just lists all the Python libraries that need to be installed, and so again you have to run this as sudo as root. So we'll run this, and this is probably just going to do nothing because I've already installed these. So yeah, but for you it's going to go through and install these packages. So okay, so that's it. So now I've done the install of everything, and I've set up that creds.py, so we can see my creds.py is filled in with all the values. So now I want to run that Python auth_web.py script. And so this is going to spin up a little web server, and it's listening on the Raspberry Pi port 5000. So I need to go to a web browser here, and I'm going to go to Raspberry Pi port 5000. Now you see it looks like it just loaded Amazon, but what actually happened is it redirected me from my Pi to Amazon's website, and it's using that special little OAuth security profile that we just created. Now I've already done this before, and so if you're starting this fresh, it's actually going to ask you to log into Amazon, and you have to click an authorize button to give it permission to access your Amazon account. So I've done that already, and so this is then you have to click this OK. So you'll get a step like this. I'm going to click OK, and it's going to redirect me back to my Raspberry Pi. So now I'm on Raspberry Pi 5000, and it says success. So refresh token has been added to your creds file. You can reboot your Pi, but don't worry about that. You don't have to reboot your Pi. And at this point, you can actually Control-C and just close out of that web authweb.py script. And if we look now, I can actually see in my creds.py, the refresh token, it actually just appended a new value to the end here. So it got this value from the website and appended it there. Okay, so now we're ready to run the script, but before we run it, there are a few little tweaks we have to make, because remember, like I said, the code by default looks like it's assuming that your audio output is from the Pi itself, from its audio jack, and its audio input is from a USB audio device. Whereas in my case, because I'm using the 0, I want the audio output to be to my USB device and my audio input to be to that USB device. So there's a few little things we have to modify. So I'm going to run nano main.py. So I'm going to edit the main.py file here. This is the main script for the code. And you can actually see here in the settings at the top, there's this device equals plug HW:1. And this is the microphone that it uses. And so this is, if you want to use a different microphone, like if you had more devices, what you can do if you run that arecord-l command, that'll list all of your audio recording devices. The card name is after the colon. So plug HW:1 means use card 1, which is my Zoom H5. That plug HW, like I described in the previous video, that's just a way to tell the ALSA sound system that use any format. Like it'll automatically convert if the Alexa software wants like 16 kilohertz audio and the Zoom recorder only gives 48 kilohertz audio. That plug HW device will do that conversion automatically. You could just use HW:1, but that won't do any conversions, and it probably won't work because most devices need like special formats. So okay, but like if you had like 2 microphones and you wanted to choose one, like you had like a card 1 and a card 2, that's where you would change in the main.py. You would change this plug HW: to like plug HW:2, for example, for a different device. Or you could even do 0 if you're trying to use like the native one on the Raspberry Pi. But I'm going to keep this as 1. Now the unfortunate thing is this code, they don't have any configuration for the audio output. It's kind of hard coded to output to the plug HW0 device, when in reality I want plug HW:1 because I want my USB device. So I'll show you there are 2 lines that we need to change here. So if we scroll down, and the code for this really isn't that complex, like it's maybe 100 lines at most, so it's not crazy at all. It's using the ALSA library to record audio. It sends it to Amazon's web service, and then when it gets the result back, it plays it using the MPEG-123 tool, which I think makes a lot of sense. It's a lot more sane than the Java code that Amazon had that uses all these sound libraries and just a lot of painful stuff. So okay, so the first line we need to change, basically anywhere you see os.system MPEG-123, like this line, this is where it's calling MPEG-123. And I need to pass it a parameter to tell it to use the plug-HW:1 device as the audio output. And so you want to do -A plug-HW:1 like this. So the full line looks like that. So I'm just adding this -A parameter because that actually tells MPEG-123 to use that audio output device. And there's one more line. If you go back up to the top, there's one inside of the Alexa function up here. So if we go way up to the top, you'll see this Alexa function. And so down in towards kind of the bottom of this function, you'll see if the status code result is 200 right here, so if it gets a successful response back, then it basically saves it as an MP3 file. And then right here, there's another os.system MPEG-123 call. So add the -A plug-HW:1 to this line, and then that'll output to audio device 1 here. Now this is all, technically that's the only thing I need to change, but I wanted to add a few extra things because there's not a lot of console output, and I like to have some output as I'm running this so that I know kind of what it's doing. So right before that os.system call, I'm going to add just a print statement that says plain response, and then after the OS system, and you can see some GPIO toggles. The code is actually written, if you have an LED connected to pin 24 and 25, it'll light that up to show its state, but I don't have an LED connected, so it's not a big deal. But that's why I'm putting in this print statement, because because I don't have the LED hooked up, it kind of tells me what's going on. So I'm going to say, okay, just done playing, so I know when it's done playing audio. And then there's another little spot I want to put in some code. Inside of the start function, at the very top, I'm going to print out ready, because when the code starts, it actually tries to play some audio, like an initialization kind of, hey, I'm running thing, but I actually don't hear anything from it. I don't know if it's like maybe there's no audio that it's playing. So I'm just putting this print statement to say, okay, once you're ready and you're listening for input and you're in your main loop, print out something that says, okay, I'm ready. So now I know I can start pressing the button, because there actually is a little bit of a race condition in the code. If you start it with the button held down, it's actually going to fail because it doesn't really realize it's this line right here. It initially starts and it reads the button state, and it won't see that the button changes. So long story short, throw a little ready in here so you know when you're allowed to start pressing the button. The other thing is I want to print out when it's listening and when it finishes listening. So when it starts listening is right here, this else if value equals 0, right above this GPIO output, so it turns on an LED. This is when it starts listening. So I'm going to just put a print statement that says listening, and then when it's done listening is right above this in this little if check. So basically once the button's been let go, then it'll save it to a WAV file and then upload it. So here I'm going to print out that I'm done listening. Oops, done listening. So again, this is just useful. It gives me some feedback so I know kind of what's going on. But really the only change that I technically had to make were the two lines, right here, this that call MPEG-123, and I'm just changing the audio output for them. So okay, so save this. And I should be able to run it. And I don't actually need to run this as root because I'm running Raspbian and Jessie. It can access GPIO without being root. And otherwise, it's just recording audio, which the non-root users can do. And it's talking to a web service, which non-root users can do. So, we're all good here. The other thing to be aware of is that this refresh token that I got by running that that auth-web.py, it's only valid for a certain amount of time. Like I would bet an hour or less maybe. Maybe it's a little bit longer. But so that's one thing to know, is that at some point that token's going to expire, and I'm going to have to run that auth-web.py again, access it to update that token. So, it's not necessarily like 100% plug and play, or like, kind of fire and forget. You're going to have to run this thing, update that auth token. I would look around though. I'm not familiar with OAuth, but there might be some libraries out there that kind of automate this process, because I'm 99% sure OAuth has a way to work with devices where you don't have to do all this manual input. But anyways, okay, so let's run main.py. We should be all set here. So it's going to start up. It checks that you have access to the internet first. Right here is when it's actually playing that audio clip when it starts, and for whatever reason I don't hear anything from my output, even though I changed the MPEG-123 line. So I think maybe the sound file just has nothing in it. But okay, now I see ready, so I know I can press the button now. So let's try it out. Let's I'll press the button. I should hear it. It should print out it's listening, and then I can ask my question, and I let go of the button, and everything should work. So let's see what happens. What's the weather in Seattle? So it's done, and let's see. Now it's playing the response.
Seattle, Washington, it's 57 degrees with mostly cloudy skies. Tonight's forecast has showers and a low of 45 degrees.
So okay, that's cool. It works, and you can see it's pretty quick. You know, so I like that I put in those print statements. You can see what the delay is between stop listening, uploading to Amazon, getting a result file back. You know, it's maybe like 2 or 3 seconds. It feels a little bit slower than Amazon's example code, but you know, there are a lot of variables there because it's talking to web service. You know, maybe my bandwidth is slowing it down a little bit here, so it's still pretty quick. So let's try it again. Tell me a joke.
Hotel does a fancy cheese stay at? The Ritz Cracker.
What hotel does a fancy cheese stay at? The Ritz Cracker. So that's it's okay. Good one, Alexa. So that's basically the project. You know, you can kind of see I like this code a lot more than Amazon's code because it's a lot simpler. You know, it's just reading audio, saving it to file, uploading it to Amazon service. I'm still not sure why my audio is getting clipped. You know, the first second or two, and that the creator of this actually noticed that too, and they added a 1 second blank audio file to try and like add some buffer to that to delay it. But I don't know. I mean, you probably need to dig in and like see, you know, what's the exact MP3 that you're getting back from Amazon, and maybe it needs like some extra padding or something added to it to make it work. But you know, this code is nice in that it's simple Python code. You know, it's hooked up to listen for a button to enable it and disable it, but you could go in and change that code and, you know, maybe just make a script that when you run it listens for input and then, you know, gets a response and plays it, and then have some other script that worries about when to actually invoke your script for it. You know, there's a lot of things you can do here. It's a lot easier because it's all just the Python code, code for it. So that's it. I think I would definitely say if you want to do a Raspberry Pi that's like an Amazon Echo and you want to play with this code, definitely check out this AlexaPi code. You know, it's pretty nice as far as I can see. The one thing I mentioned though is that I had a lot of problems. I couldn't get the setup.sh to run. So, you know, go through like I showed in the video here how to manually configure it and run it. You know, I think that's probably a little bit easier to do instead of trying to debug kind of why its setup script doesn't seem to work for some people. So that's it, I guess. Let's see if there are any questions, maybe throw them into the chat right here. Let's see, let me change the view back to the main camera here. So, okay, there we go, back there. So yeah, I don't see too many questions. I see one question: can it tell if it's you or not? Good question. I don't think Alexa, the voice service, has any like audio recognition capabilities. That would be kind of cool. I mean, it wouldn't surprise me in the future if they do some stuff like that. But as far as I know, no, it doesn't have any recognition. I think I don't know of any speech recognition like to recognize a person. I've used the library called Sphinx and Pocket Sphinx, which is like a really nice speech to text kind of library. Like it can listen to something and then transcribe it effectively. But I don't know of anything that's like, you know, recognizing a user. That would be kind of cool. I'm sure something's out there, but interesting idea. So, but the one neat thing, I mean, as far as I know, this Amazon Alexa voice service, there are some limitations, like you know, it won't use Amazon Music service because I didn't check that box. I think there's certain other services that it won't use, but it does, like you can use the to-do lists. I actually had a reminder alarm that worked. That was with the Amazon code that I tried. I'm not sure if it works with this AlexaPi code, but that works. I actually just saw, and maybe it's been out for a little while, but IFTTT, the if this then that service, has an Alexa channel, and it looks like you can set up a trigger so that, like, if you say, you know, hey Alexa, trigger, you know, turning the blinds, like, you know, closing or opening the blinds or something, you know, it can talk to all those services. So I think that would work with this too, but I haven't tried it, so it's definitely something worth experimenting with. So I think that's it. I think we'll call this an end to the stream. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can see this video and all kinds of other fun projects there. And then subscribe to twitch.tv/Adafruit. That's where I stream these live to. And the next stream, I'm going to do one Friday. I'm actually going to do it earlier on Friday, because Friday afternoon I'm going to be busy. I'll be out somewhere. So I'm going to do part 4, which I think I'll probably make it the last part in the Raspberry Pi Internet Things series. So if you like to do Internet of Things stuff with the Raspberry Pi, check it out. I've done 3 videos so far where I've basically created a little device, like an LED and a button and a temperature humidity sensor that are connected to Raspberry Pi. And then I've kind of walked through building a nice little web interface for them so that you can see like a chart of the temperature and the humidity update on a web page in real time. So real kind of nice little, bootstrapped kind of process of, here's how to create a thing. So yeah, tune in Friday, early Friday, probably sometime around like maybe 11 Pacific, 1 p.m. Eastern time or so. And then also during the week, so check out Wednesday, we'll have Ask an Engineer and Show and Tell. That starts at 7:30 Eastern on Adafruit's YouTube channel and Twitch and all those places. And then also keep an eye out for the Desk of Lady Ada, where Lady Ada likes to stream interesting stuff that she's working on. So check it out. You can find all the fun stuff. So thanks a lot, and I'll see everybody on Friday. Thanks for watching.